Hello and welcome to the video. Before we get started, if you'd like to provide input on future content and get our weekly newsletter, click on our survey. The link will be below. We also have a report on Ethereum 2, along with a bonus report on why you should learn Solidity now. Again, the link will be below. Now on to the video, and thank you. Okay. So tonight is the second part of our series on Motoko, and we're going to talk about each microservice being an actor. So an actor is similar to an object. It has its own state, and its interactions with the outside world, with all the other actors, is asynchronous. So what that means is the message is passed, and it goes out there and it's going to return when it returns. So you don't know, you're not sitting there necessarily waiting, just like when you call a method and you sit there, get the response, and then you carry on. You don't necessarily have to do that with asynchronous. It can go off and do its thing, unless it needs to. And we'll get into that. There's always somehow there's a result, but obviously you can have things go wrong, and maybe the other actor is not operational, that node is down, or what have you. So the nice thing about Motoko is that it provides a very nice syntax. Basically, it's like a normal call to another object. If you see here, we have let result. It's just like you were calling a class method in Java or something. Difference is here. Because it's asynchronous and because it needs both of these, it's going to say await, which says wait till you have both of these before you process and carry on. And it supports this very well, and that's because that's the whole basis of it. It has two things that we're going to get into in more depth, but we have async and await, and async says this, we're going to get some value back in the future. Await says it's going to synchronize on some future value that's coming. And you see the concept of synchronization in more traditional languages. But you can see how easy this syntax is here, as opposed to having to, create callback functions and so forth. It says, when we get a result, go do this. It's a lot nicer syntax. Again, each actor has its own state. And we're going to get into more about private mutable states. Types of static. This is a strongly typed language. It knows ahead of time what the types are, and then the compiler can validate it. And it has a way of preventing errors because you pass the wrong type in. It says that it also uses these types of methods or techniques, I think that's a better word to use, to prevent null pointer errors. So each value is checked by the compiler, the use of each variable. So they claim here it provides a trusted compiler verified documentation. I don't know how much more this is than strong typing. If you try to compile a C or a Java program and you try to pass a string when it's expecting an integer, it's not going to compile. So it provides a very nice language that's designed to be very easy to use, designed to check things ahead of time. So what have we learned? We learned that Motoko is basically, you have a bunch of actors that are communicating by passing messages and waiting for them to come responses and so forth. And sometimes it has to wait, sometimes it doesn't care. It just does it. It's very strongly typed, so it knows ahead of time what it's expecting and can check that, preventing errors during runtime. So if you found this useful, then please give a like. Please share it with your friends. Please subscribe to the channel, ring the bell, and we will continue on with this, and I will see you next time. Take care.